You missed some, Amy. Got to catch up. Okay, functions. Yes, Brian?
Should we write this?
Yes, you should be writing this.
You want me to delete that?
Functions. Today is the 16th. No, that's fine. Keep going. Today is the 16th. Today is the 17th. Thank you. And, all right, guys. We are learning about functions. Who here has heard the word before? Who here remembers what it means? That's a shorter list. Okay. Philip, what do you think?
Is it an equation that represents a line?
A line sometimes. So that's not really a working definition, because a working definition shouldn't only work sometimes. Mimi?
Don't functions have variables?
Again, very general. Okay, very, very general. I think I'm going to go ahead and give you this one. Okay? A function is a relationship between two variables with an important condition. With an important condition. I have a way to define this that is very accurate. That will sound confusing. I have a way to define this that is somewhat limited but will seem familiar to you. Do you want the confusing one or the familiar one first?
Familiar.
Confusing.
It's easy to get the confusing one first?
No, the familiar, then the confusing.
No, the confusing, then the familiar, because then if you get the familiar, you understand the confusing better.
Let's try it that way. We'll try confusing, a little bit confusing first. Okay, if you paid attention in science, this might not be confusing. But a function is a relationship where there's one way to phrase the condition of a function, okay? There is only one occurrence of the dependent variable for each point on, oops, starting to write it wrong.
I know what a function is.
Each point on the independent variable. I'm glad you do, Nini, but it's a little late to we're defining it.
Well, no, wouldn't a function also be like if you had like the f and then you have like two numbers and then you plug them in?
That is one thing functions does. But again, you're doing characteristics. I'm looking for definition. Okay?
You spell current, right?
I think so. I wouldn't bet like a lot of money on it, but I think I did.
Okay.
Okay, there's only one occurrence of the dependent variable for each point of the independent variable. That's a slightly more confusing way to put it. Here's the slightly more, oh, Shadow, you don't have to take notes today if you're since we're working that. That can be your note taking. So if you think you can do both, that'd be great.
I can write them for you.
Okay, here's the other way to write it. There's only one y for each x. There's only one y for each x. Let's double check something. When we're graphing a line, like Philip mentioned,
Did you write that?
yeah, it's on a Cartesian coordinate plane. You guys heard of that before?
Nope.
Maybe not by that word.
Use another one.
I heard coordinate plane, not Cartesian.
Coordinate plane, but not Cartesian, the first part?
Yeah.
Okay, on the coordinate plane,
What does Cartesian mean?
I'll get to that in a sec. The y-axis is the vertical one. The x-axis is the horizontal one. Okay? So, everything okay, Philip?
Yeah, there's some floating through the air. It was really strange.
Hopefully this is not the
Light,
beginning of
I
a
know
Mark
what you're
Wahlberg
talking
movie
about.
where we're all going to start dying.
The line, I catch it.
Okay. Only one y for each x is the simplest way I can think of to define a function. And functions are things that we're going to deal with on this two-dimensional coordinate plane. Okay? Now, I'm going to move over here and start telling you guys where some of this comes from. 1637. This guy named Rene, that's a year. In 1637,
Write that too.
yeah, just write this part. Now, well, you have to write down everything I'm going to say. He wrote, I'm probably going to misspell this, and anyone who speaks French
I do.
could correct me. La geometry? The geometry?
La géométrie. It's with an A. L-A.
It'd be L-A, are you sure?
Yeah, la géométrie.
Okay, very good. Excellent. I've never been sure.
Yeah, I know your little sister was cussing at me in French.
She was like,
Okay, anyway, guys. Rene Descartes. He's the guy who invented most of what we teach in modern Algebra 1. Okay?
I don't like it.
A lot of people don't. Here's the backstory on it. Rene Descartes was mainly a scientist. Okay? There's actually a very sad story behind this. He wanted to figure out better scientific methods primarily to beat viruses. The reason why is he had a 5-year-old daughter who was killed by a virus. And he spent the rest of his life trying to figure out better scientific methods. To do this, he revamped the math of the time. He's most known for two things. One, he's got a very famous quote. In Latin, it's cogito ergo sum, which is, I think, therefore I am. He's the guy who first said that. And what he was talking about is basically we can only know what we understand with our own head. We can't really prove whether or not we're hallucinating or not, but we got to assume we're not hallucinating. This desk is really here. I'm really here talking to you. I'm not dreaming, and go from there. He was trying to reinvent science from very first principles like that. He came up with this graphing system. There's a story. It's a little hard to prove something that took place almost 400 years ago. There's a story that he was laying in a little cottage, like a bed and breakfast, along the road. And he was staring at the ceiling, and the ceiling had tiles on it. And he was watching a fly go across the tiled ceiling. And as the fly went, up 2, over 1, up 2, over 1, he realized it was following a line, and he had the idea for graphing the slope of a line on a coordinate plane.
so the fly gave him
Well,
the idea?
Well, yeah, the other weird part of the story is one thing that might have been the case based on some other things he wrote down about the time is when you went to a bed and breakfast in France in the early 1600s, they tended to make you dinner on whatever they got out of their garden, and a fairly common occurrence back then was for people to accidentally be fed psychedelic mushrooms. So it's entirely possible he was slightly tripping at the time. However, when he invented graphing and algebra, he wrote under the Latin name Cartesius. And that's why this is sometimes called, at least in old textbooks from my childhood, the Cartesian coordinate plane.
So it was named after.
Yeah. Now, Rene Descartes made a decision while he was inventing this. It was an arbitrary decision. I will try and distinguish things we come across in math into two very broad categories. Some of it will seem to be the math that the universe or the good Lord or whatever you believe in handed us. 2 plus 2 really does seem to equal 4, no matter how you look at it. Okay? Well, we made the names up, but you could change the number. But regardless of how you label it, 2 of these and 2 of these makes 4 of these. That seems to be pretty unchangeable. Other things are man-made and arbitrary. For example, Rene Descartes decided that on his graphs, he would put an independent variable here and call it x, and he would put a dependent variable here and call it y. That comes from him. Here's what he meant by independent and dependent. Yes, Nimi?
Never mind, you're going to answer my question.
Pardon?
I was going to ask you what you meant by independent.
Excellent. I'm about to go into that. Okay. When you're looking at a graph of like something of money or economics or science, any of your science books or anything, what is the most common thing you see on the horizontal axis? Most commonly thing. You see a graph about money, the stock market changing. What is this usually counting, indicating?
Months.
Time, months, years, something. It is very often time. If you're conducting an experiment, you're boiling water and seeing how fast it takes to boil, you're watching a plant grow, you're doing something like that, then it's usually time is horizontal. Could a time have gone up here? Yes, but today that would look funny to us because we've had 400 years to get used to it. But that's just a decision Rene made. He said, I'm going to put this down here. Time is sort of your ultimate independent variable. Unless you're doing a physics experiment, you're moving close to the speed of light, time keeps moving forward and we can't control it. If you're watching a plant grow and measuring it for an experiment, how tall the plant has grown often depends on how much time has passed.